Hello, everyone. Thank you so much for joining us for this week's PAVE virtual panel. We're going to start really shortly. As a reminder, you will be able to find this recording as well as all of our other previous panels on our YouTube channel, on our website at pavecampaign.org, or on our social media channels. So, welcome to PAVE's 129th virtual panel. Today, we are going to be talking about infrastructure and autonomous vehicles, highlighting a new NCHRP research project. And before we get started, I want to call out a link in the chat box. I will add it here that our panelists would love for you to complete. But my name is Caitlin Magny Miller. I'm PAVE's Communications Director, and I'll be moderating today's discussion. And I want to start by introducing our guests. We are joined today by Ashley Nylen of USDOT, Britton Johnson of Kimley-Horn, and Samantha Anderson of Kimley-Horn. So let's go ahead and get started. And Ashley, I'm going to start with you. Can you start by providing some background on this project?
Yeah, thanks so much, Caitlin. I just want to start and say thank you to PAVE for hosting the webinar and certainly to NCHRP for the support that enabled the research project that you're all going to hear about today. My role here is I serve actually as the panel chair on the NCHRP project. It's named 210224, which features hypotheses on infrastructure modification improvements in the automated vehicle operational design domain. Very quickly, for those of you that are unfamiliar of the NCHRP program, certainly welcome or encourage you to go over to the website and take a look. But the program has been in existence for over 50 years and is funded by the member states of the American Association of State Highway and Transportation Officials, or AASHTO. Projects such as the one you'll hear about today do come directly from identified need from stakeholders to address safety, mobility, and efficiency on our roadways. NCHRP's annual research program is driven by the stakeholder needs with direction from the chief administrators, the other staff of the highway and transportation departments of AASHTO, and the Federal Highway Administration. Furthermore, the NCHRP panels themselves are primarily served largely voluntarily and beyond sort of the normal workday duties by state DOT practitioners who ultimately oversee and guide each of the research problem statements and what eventually becomes the contracted work. NCHRP panels may also feature participants from industry and always include a Federal Highway Administration liaison. The 2102 series, where this project lies, was actually established back in 2015 and serves to explore the impacts of connected and automated vehicles, or CAVs, on state and local transportation networks. This project in particular focuses on the evaluation of potential operational domain requirements and recommendation strategies to maintain, revitalize, and create infrastructure within the operational domain to foster safer, more accessible, and more rapid adoption of CAV technologies on the roadway. The research that you'll hear about from Britton and Samantha has two phases. Phase one focuses on the development of CAV infrastructure guidelines, which included a literature review, industry outreach, development of the guide itself, and then phase two focused on the validation and refinement of the guidelines with on-road AVs, simulator research methods, micro-simulation, and then feedback from the infrastructure IOO community. You're probably wondering why I'm involved in this, given that there's another federal highway liaison. My involvement actually stemmed from my previous role when I was at a state DOT leading their connected and automated technology efforts, and I was nominated during my time there to serve as the panel chair, and I'm elated to say that that role ended up moving with me when I moved over to the USDOT a few years ago. I'm really excited for you all to hear about the project objectives, their progress, their early findings, and then also how you can stay informed as the project moves towards completion in the next year. I do want to recognize that this project would not be where it's at today without the enduring commitment of the fellow panel members who review deliverables, participate in meetings, provide their technical and their practical lenses, all in addition to their overwhelming workload that they do to make sure that our roadways are running safely and smoothly. So I'd like to take a moment very quickly to recognize fellow panel members who include Adam Schell from the Iowa DOT, Suzanne Anderson from Arizona DOT, CJ Smith from Mississippi DOT, Tracy Larkin from Nevada DOT, David Yang from the AAA Foundation for Traffic Safety, Sarah Hernandez from the University of Arkansas, David McDonald from Hanson Professional Services, and my colleague James Gray, who serves as the Federal Highway Liaison. And lastly, Chris McKinney, who is our Senior Program Officer with TRB National Academies. I do recommend you take a look at the NCHRP program if you're unfamiliar. And of course, today is just a teaser about this specific NCHRP project. Britton will provide you information on how you can access any links of the project related to phase 1 and other project information. And please do not hesitate to reach out to Chris McKinney with TRB or Britton Johnson from Kimley-Horn. So with that, Caitlin, I will pass it back to you. Thanks so much.
Thank you, Ashley. Always great to hear from you and great background as we sort of dive into this discussion. So, when we talk about AVs operating on public roads, obviously it's not just about the vehicles. The environment really matters too. So, with that in mind, why do AVs need infrastructure modifications to function optimally? And what are some of the key factors in their operational design domain, or ODD, as we say, that influence how they interact with our roadways?
No, absolutely. Well, thank you again for having us, Caitlin. As Ashley said, this project was initiated by infrastructure owner operators, or IOOs, to better understand how their infrastructure influences AV operations. So just to give a little bit of context for today's discussion, we're considering all levels of automated driving systems. So while we may occasionally refer to them generally as AVs, our research covers low levels of driving automation, such as adaptive cruise control, lane keep assist, which are really ADAS, our advanced driver assistance systems, as well as higher level of automation, such as the robo-taxis we're hearing about on the news. Every driving automation system, whether it's a driver assistance system or it's a fully automated system, has an operational design domain, or ODD. This ODD defines where and under which conditions that automated driving system is permitted to operate. So the ODD requirements may include factors like the road type, surface condition, operational speed, lighting condition, and weather. The ODD itself is really defined by the vehicle manufacturer or the technology provider. So the exact ODD of a lane keep assist, for instance, in my Subaru and your Honda might have slight differences. However, in general, many consistencies are going to exist between similar applications. So keeping with this example of lane keep assist, most manufacturers' ODDs would include having clearly visible lane markings. Some of that is influenced by the IOO, where the visibility of the lane markings could be influenced by the lane markings themselves, so their quality, their contrast, their visibility, as well as road surface quality, lighting conditions, and weather conditions. So to circle back on your initial question, it's not just about the onboard vehicle technology. While AV technology continues to advance and newer systems have had some success overcoming some infrastructure challenges, there's still a lot of opportunity for IOOs to promote and accelerate AV deployments by enhancing physical infrastructure and introducing some digital infrastructure as well.
Really interesting. Obviously, this guidebook didn't happen in a vacuum. There's a lot of input from research and industry alike. What are some of the common challenges that AVs face with our existing infrastructure, and how did you sort of uncover those pain points during the research process?
Yeah, so that's really a great question. And so our first step with really starting this project was to gather a strong foundation of insights from both previous research as well as those published reports. And then we further supplemented this information by having conversations with AV industry representatives. So that included those from AV technology companies, vehicle manufacturers, as well as AV testbed facilities. So with starting this extensive literature review, we covered academic and federal research, as well as the regulatory information from the MUTCD's new chapter regarding AVs. And this review of literature really demonstrated that while there is a growing body of information on AV interoperability with our physical infrastructure, there are some big gaps in that, especially when it comes to those real world deployments. So we found that most research findings are actually based on non-production grade driving automation technologies. And these may not actually reflect the challenges that are experienced by those deployed AV systems. But this is the case because most companies deploying these AV technologies are understandably cautious about actually publishing the details regarding these technical limitations with their systems, as well as the reports on which these systems actually disengage. So really, in order to bridge this gap, we conducted these targeted interviews with the broad range of AV industry players. So this includes those working with personal vehicle driver assistance systems and also those working with fleets of robo-taxis. And this diversity of engagement was so crucial because the technology relied upon to operate varying levels of automation is really impacted differently by our infrastructure. And so through these conversations, we were able to add context and specification to the findings from our literature review. And then we were also able to summarize a few consistent infrastructure challenges that really impact vehicle automation.
Thanks, Samantha. I'm curious if you can talk a little bit about how collaboration with AV developers and industry players shape the recommendations in the guidebook.
Yeah, absolutely. So as Sam mentioned, the AV industry input was really, really valuable in narrowing down the vast amount of literature and information that's out there, and really helping us focus in on key challenges experienced by deployed AV systems. So from our discussions with these AV developers and industry leaders, we had three primary themes emerge that I wanted to talk about today, specifically related to the physical infrastructure. The first one is HD maps. HD maps have really helped overcome a lot of limitations associated with physical infrastructure, especially for higher levels of driving automation systems. But many driver assistance systems don't use HD maps, and even systems that do use them still rely on infrastructure verification. So most companies still rely on the perception and detection capabilities of machine vision systems. So second, consistency is key in all aspects of physical infrastructure. We heard that over and over. So whether it's pavement markings, traffic signs, signals, geometric design, temporary traffic control, etc., maintaining consistency across jurisdictions is really critical for training machine vision algorithms to allow for the scaling of AV deployments and ADAS deployments as well. And then three, in general, physical infrastructure improvements that help driving automation systems also help human drivers. So said another way, the vast majority of the physical infrastructure improvements the AV industry representatives recommended will also benefit human drivers as well as their automated driving systems. And so beyond just that and helping understand where these recommendations are coming from, a few representatives highlighted that one of the biggest challenges for operating an AV in the wild, if you will, is really the unpredictability of other human drivers sharing the road with the AV. And their point with this was that in many cases, infrastructure deficiencies cause confusion, and that results in erratic human behavior that is actually more dangerous and more difficult for the AV to navigate than the infrastructure itself. So that's kind of what we heard about physical infrastructure. We also asked a little bit about digital infrastructure. And a few opportunities the AV industry representatives highlighted were interest in high quality real-time data, especially regarding dynamic traffic control or routing scenarios. So they were talking about work zones or special events or those unique conditions. They also highlighted a high interest in notifications and information about emergency vehicles, so where they are and what their routing is to avoid conflicts in these emergency scenarios. And then while a few AV representatives expressed some interest in the broadcasted SPAT, so your signal phase and timing type messages, they also indicated that technology would really need to be more broadly available to make their investment into that technology worthwhile. So ultimately, this AV industry input was critical for grounding the recommendations that we introduced throughout the guidebook.
Fascinating and great to hear how you really incorporated the industry and took to heart their suggestions and their feedback. So switching gears a little bit, the guidebook outlines a number of modifications that can support AVs more effectively, and I want to dig into some of those. From the guidebook, what would you say are really the top infrastructure improvements that state and local agencies should be thinking about right now?
Yeah, so the AV Infrastructure Guidebook was really developed and designed to be comprehensive. So we cover many elements of physical infrastructure. So from pavement markings, roadway surface, and geometric design to traffic signs, signals, and then temporary traffic control. We also discuss those opportunities associated with the digital infrastructure as well as transportation policies. So within the physical infrastructure domain, we found that really the lowest hanging fruit is that infrastructure owner operators can really focus on doubling down on maintaining their existing assets. So as we mentioned earlier, what is good for an AV is also good for the human drivers. And infrastructure owner operators have been focused on maintaining roads for human drivers for hundreds of years. So by simply improving the visibility as well as the consistent application of pavement markings, signage, and signals, this can really make a big difference.
Great feedback. Um, I understand that you've been conducting some field testing and driver simulation studies as part of this project. Can you talk a bit more about how that research is helping shape the guidebook's recommendations?
Absolutely. And so, as Ashley introduced in our introduction, our project is split into two phases. The first phases was building this foundational research, which included this background research, talking to industry, and that led us to the draft guidebook that we have now. And we call it a guidebook, but it's actually a website. It's a web resource. And then the second phase is really our efforts of doing events like this, of getting input, getting outreach as well on those draft guides, as well as our partners at the University of Cincinnati are actually doing field tests to validate pieces and add context to the recommendations that we've pulled together. So as I mentioned, we've been really fortunate to partner with the University of Cincinnati's Dr. Munir Nizal and Dr. Muhammad Ahmed. Dr. Nizal and Dr. Ahmed's teams at the University of Cincinnati are conducting a series of field tests as well as driving simulator-based tests to fill some of those gaps, like I mentioned, from that foundational research we did in the first phase. And ultimately, the vision is that these findings will get included in the final guide, which will be published late next year. So the field testing specifically, it's being done with a production grade level 3 automated vehicle. The research team has driven that test vehicle across multiple routes dozens of times over the last few months to identify locations and reasons for disengagement of the automated system. So the outcome of their synthesis of why is the automated system disengaging will help lead to additional details in the guide. Some of the early findings that they've seen to date, and they're about, I would say, 1/3 of the way through their testing at this point. Early findings have led to the development of some more specific thresholds for pavement marking visibility, for instance. So these include the contrast, color vibrance, and texture of pavement markings. They've also seen in their testing some challenges with the automated driving system effectively detecting potholes and railroad crossings. The driving simulator tests, on the other hand, are really focused on how users of driving automation systems, primarily ADAS, so our level 1, level 2 systems, are using those automation capabilities and how their use of those capabilities change with modifications to infrastructure. So the team is actively recruiting participants, and they're going to be conducting driving simulator studies in a work zone scenario, as well as in a multimodal urban environment.
Great. Now, you touched on this briefly a little bit earlier, but I want to come back to it. Digital infrastructure is coming up more and more in conversations about the future of AVs. Can you talk about how the industry is anticipating the benefits from it and what they see as both the challenges or limitations right now?
Yeah, absolutely. So digital infrastructure really encompasses things like connected vehicle data exchanges, vehicle to everything communication, and real-time traffic information. And all of this really has a huge potential to help AVs operate more safely and reliably, especially in those complex environments like work zones, school zones, or during unexpected scenarios. So, from the industry side, there is clear recognition that digital infrastructure could be beneficial. It can help AVs overcome the limits of those onboard sensors, especially in scenarios where the vision system alone might actually struggle. And so this is in cases where there's poor weather conditions, unpredictable traffic, or in places where the pavement markings are just deteriorating. So digital infrastructure allows vehicles to actually see beyond the line of sight by pulling in data from the infrastructure itself, and this actually expands the vehicle's operational design domain. But with that being said, there is some hesitation from the AV developers. So they've told us that their systems, or that they can't really design their systems to actually depend on the digital infrastructure until it's deployed widely and consistently. And so they've said that there's really no guarantee that a system will always have access to the data that it needs, especially across different jurisdictions. And that's really the huge challenge right now. So for now, digital infrastructure is really viewed more as a supplement rather than a foundation. But this really is an area where collaboration between infrastructure owner-operators and the industry is just so essential. So if we can really scale the deployment and standardize how the data is shared, whether it's through the APIs, cloud-based platforms, or through cellular vehicle to everything, then we can help AV developers begin to build a more robust system that is actually able to leverage that digital infrastructure.
Great points. Yeah, I think consistency is really important in that context, as you said. Now, for agencies that are interested in starting to make these improvements, it might feel overwhelming. So let's talk a little bit about the practical side of things. In what ways are infrastructure owner operators currently learning to prioritize and implement these types of recommendations?
Yeah, absolutely. You're right. I think it can feel very overwhelming. I mean, especially when you just consider the rapid pace of technology. What we know today may not be true tomorrow. What's flashy today could be sunset in a few years. But that said, a few practical action items that we're seeing agencies start with are readiness assessments and pilot programs. So, AV readiness assessments. We've seen that agencies are starting to evaluate their current infrastructure against recommendations such as the ones we're discussing today and that our project is working on producing. These assessments are intended to set a baseline for where the physical infrastructure improvements are needed in their specific jurisdiction to advance AV deployments. The second piece of those pilot programs are really a practical and a popular strategy for advancing infrastructure using a variety of different funding streams without trying to overhaul the entire network at once. So agencies are finding success by really narrowing the scope of these deployments to high value corridors for which these targeted AV deployments or applications may provide value to the community or help evaluate a specific application. But we're also seeing that other successful strategy, less related to the technology itself and more related to the agency's organizational readiness. So a few quick examples. The first one is staffing. Keeping up with all of this is really a full-time job. In fact, a lot of agencies are starting to see that and introducing full-time staff to monitor, manage, and promote AV-associated innovations within their agencies. The second thing we're seeing is multidisciplinary collaboration. Preparing an organization for AVs goes way beyond the planning and engineering departments. There are very real impacts to contracting and procurement, IT and OT, policy, legislation, and of course, maintenance and operations. So we're starting to see agencies prioritize this collaboration internally to further advance innovation. Third, very similarly, we're seeing a lot of multi-agency collaboration. We're seeing an influx in peer agencies sharing data, lessons learned, cost models, and many other things. And this collaboration is happening through peer networks like TRB, so through projects like ours, which is an NCHRP project, through AASHTO, ITE, and many other mediums as well. We're also seeing this naturally occur across geographic borders or through pooled fund studies where agencies are sharing lessons learned. And so the idea here is that agencies and organizations are starting to learn from one another to more quickly advance the state of practice. And then fourth and finally, funding. Agencies that understand their programming and funding cycles and specifically how to align AV investments with those funding cycles are better positioned for sustained prioritization of these AV investments. And so really when building funding resiliency, it's not just about that upfront capital investment, but also ensuring that there's long-term funding for operations and maintenance that includes both the resources needed, the software needed, and the staffing needed to maintain those systems. So really, ultimately, the research conducted for this project has demonstrated there's not a one-size-fits-all approach for AV readiness, and that success is really unique to each agency's mission and goals and specific needs.
Right. Sort of building on that, can you share any examples of pilot projects or early adopters who have implemented the changes and had success?
Yeah, absolutely. So, really, one of the most encouraging things that we're seeing is that agencies across the country are moving forward with the connected and automated vehicle implementations. And they're moving forward in ways that really reflect their agency's unique operational goals as well as their regional context. So, I want to walk through 5 different examples that really show the range of what's happening on the ground right now. So first, there are several states like Colorado, Minnesota, Missouri, Florida, and Ohio. They've begun deploying and evaluating autonomous truck-mounted attenuators. And so these are essentially work zone safety vehicles that can be operated without a driver. And so it's protecting roadside crews during lane closures, as well as other maintenance activities. Second, we're seeing progress in automated public transit pilots. So the Cassie shuttle with North Carolina DOT is just one example of this, and it's been used in various locations across the state to evaluate first to last mile service options. And same with Houston Metro. They're exploring how AV shuttles can actually supplement their existing fixed route services. Third, moving into Texas, the I-45 Innovation Corridor is really pushing the envelope. They're testing a variety of CAV applications, including the use of Aurora's Level 4 freight trucks for long-haul highway operations. And fourth, the Contra Costa County's Innovate 680 program in California is using connected infrastructure, real-time data, and smart mobility tools. And they're using these to improve highway operations through traffic management system modernization. And finally, Peachtree Corners in Georgia. They've taken a very integrated approach to AV readiness through their Curiosity Lab initiative. So they're deploying connected infrastructure like traffic signals that are broadcasting SPAT data, dedicated AV shuttle lanes, and active cellular vehicle to everything pilots. They've also launched an autonomous electric shuttle that's operating on a 3-mile route and is supported by 5G and real-time signal communication. So really, overall, all these projects are highlighting how agencies are testing, learning, and iterating in real time as these technologies continue to mature.
Yeah, great to hear some of the examples out there. Some friends and partners of PAVE mentioned, so wonderful to hear that. Now, we have just a couple of minutes left here, but I want to wrap up with one more question, which is, as we look ahead, both technology and policy, obviously both moving very quickly, what are some of the trends or next gen AV capabilities on the horizon that might require us to rethink today's infrastructure again?
Yeah, and that's a really great question and an important one. So we're seeing significant progress in areas like machine learning, predictive modeling, and vehicle to everything communication. And these advancements are really pushing AV systems to become more adaptive and less dependent on traditional infrastructure cues. So, for example, there are technologies like Comma AI that really don't rely on pavement markings at all. And so we've actually had people challenge our findings during presentations, and they're asking if AVs like this exist, then why are pavement markings still a priority? And while this is a valid point, it's also a limited one. So while some systems may no longer need lane markings to operate, they really represent a small fraction of the broader landscape. And the reality is that many current AV systems, as well as all human drivers, still rely heavily on physical infrastructure. And until we reach the full scale level 4 and level 5 deployments, which is still years away, we really need to support a mixed environment where a range of technologies can coexist safely as well as reliably. So the takeaway is flexibility is key. So our infrastructure needs to be robust enough to support today's human drivers, as well as the early stage AV systems, while also being adaptable enough to accommodate the evolving technology of tomorrow. And that's really how we can future-proof our roadways.
Really good point, Samantha. I think, none of this is happening overnight, and we're going to have to accommodate a lot of different systems as things change. Any closing comments from either of you before we wrap up here today?
Yeah, I just have a couple very quick things. So in the chat, Caitlin provided that brief survey. We would love all of your insight through that survey. That will help us refine this final guide before publication. Second, if you're interested in seeing the draft version of this guide, please fill out that survey, leave your email address, and we are happy to send that to you. We should have a copy of that in the next couple of weeks. So again, it won't be fully published, it's that draft version, but we'd love to get your input on it. And third, if you want to see, we have a executive summary that summarizes all of the information from our phase 1 of this project that's available on the NCHRP 2102-24 website. And so if you go to that site, scroll to the bottom, there's a link to that early findings document as well. But lastly, I just want to thank PAVE for hosting us and for all of you all for joining us. Please don't hesitate to reach out if you have any questions.
Well, thank you, Britton, Ashley, and Samantha for your time and your insights today. Like I said, we will be posting the recording of this if you missed it or want to share. And thanks again to all of you who joined us today.